Sure.
Hello, everyone, and we are the Ignite Improving Students STEM Identity Through Design and Tinkering team. This summer, we've been working with the Ignite program to analyze the data. So, what is Ignite? Ignite is an engineering education program for middle and high school students in the Durham area, with the goal to help students learn engineering skills while designing solutions for challenges in their community, while also strengthening their engineering and community identities. We have two different types of learners and makers in the program. So, the learners are middle school students. They tackle either the health, water, or light themed problems in a more taught approach. And for the makers, they are high school students and they have a more independent approach where they find and design solutions for problems of their choosing.
So we had three main goals for our team. First was to clean the data. We scrubbed it, de-identified it, put in a data frame that we can access for our second step, which was to explore survey trends. So we conducted exploratory data analysis to see trends, gaps, influential factors that we can use for our third step, which was to create a predictive learning model, which basically predicts students' learning outcomes and growth based on the patterns that we found from the second step. So this looks at STEM attitude by gender, and from this, we're able to see that female participant has showed decreased confidence in math abilities and reduced interest in additional math courses, while male participant demonstrated improvement in both areas. There are also some engineering engagement patterns where female participant increased their interest in engineering courses, while males showed decreased interest, and female demonstrated significantly greater improvement in recognizing design solution needs compared to males.
Here we graph the engagement levels of each session across all of the learner courses, so the light, water, and health courses, and separated them by whether they were conducted in person or over Zoom. We found that overall engagement levels are significantly higher in the in-person sessions compared to the Zoom ones, and we found this to be statistically significant. We created similar graphs for each individual course and observed similarly statistically significant trends.
So we also looked at students post pre-improvement with absence and average engagement. Out of the 29 question, we just pulled out five that were most that showed a greater correlation. And we're able to see that students with stronger community ties show better attendance and engagement, and that teaching design thinking builds transferable skills and connecting learning to real world STEM careers boosts motivation by highlighting practical values and future opportunities.
And next, we'll look at the high school insights. So for the makers, we grouped their pre-post survey scores based on different attitudes and identity scores. And as we can see, most of the scores did increase throughout the program. And while we saw a few decreases, these were not statistically significant. We also looked at the pre-post survey confidence scores specifically by grouping into the three engineering design phases. So here, create, and deliver. And as indicated by the asterisks, we can see that there were many significant increases throughout the program, which means that Ignite is impacting the maker's confidence significantly and improving it.
So we also created a predictive model in order to help the people running the course get some insight into what makes for a successful student at the outcome of the program. And we, for the prediction model, used a combination of pre-survey and aggregated engagement data for each student to predict what each of their post-survey responses were going to be. We made this using a random forest regressor with 100 estimators. And while not all of the predictions were able to create a high R squared value, we did have several, including community attachment and the ability to solve different difficult problems that were very well predicted using our predicted model. So to give an example, next slide. We have here the predictive features for the outcome. I have a strong attachment to my community. And you can see here the types of features that are strongly predictive of this outcome. Of course, the student's initial survey response, but also a number of factors related to the opportunities they have to take engineering courses or to develop other design solutions. All in all, we hope that the predictive model will give the people running Ignite the ability to make more informed decisions about interventions that they might like to make or changes that the program should include in the future. And that's the end of our presentation. Thank you so much for taking the time to listen.